P4.5 series circuits. Okay, we're going to look at the different rules to do with series circuits. So the first one that I'm going to show you is a simple series circuit. Can't get any more simple than this. And the reason why it's called a series circuit is because the components happen in series. So if I add on more components in series, you find that the electron, as it's going around that circuit, so it goes into the light bulb, it goes into that resistor, then it goes into that resistor, and then it goes back. They have to go one, then the other, then the other, then the other, and then back home. Okay, if I add in more cells, it says this one's pushing out electrons, then this one's pushing out electrons, then this one's pushing out electrons. And there's some rules that go with that. But the key thing is, if you think about your electrons in your circuit here, they've got no choices. They can't go anywhere else. There's nothing else they can do. So that's how we know it's a series circuit. Okay. So what effect does that have? Well, let's have a look at the energy that we're supplying first. So what effect does having 3 cells have on my circuit? Well, having 3 cells has the effect if each one of these cells is 2 volts, then the total voltage in my circuit is going to be 6 volts. So the equivalent voltage provided by one cell of these 3 cells in a battery is 6 volts. All I did was add them together. Okay, because they're all going the same way. If they were going the opposite way, I'd have to turn them around. Okay, so next up, what we've got is, what do we do with the components that are in that circuit? Okay, so if I add in some components, and let's say I want to know what the current is in this circuit. So I have to add an ammeter in series. And these are my 3 ammeters. Okay? Ammeter, ammeter, ammeter. And I like to think of this one in terms of water and a hose pipe. Okay? So if you think about it, the rate, so remember the current was the rate of flow of charge. And if I've got in this pipe here, I've got 2 things slowing it down. But what I'm concerned about is how fast it's flowing around the whole pipe. So I'm pumping the water in and it's going around the circuit, and these 2 things are slowing it down. But that doesn't mean that these go faster because they haven't been slowed down yet. What it means is they all go round at the same rate. Okay? So because they've all got to go around at the same rate, it's like a hose pipe. You can only go as fast as the narrowest bit. Otherwise, you've got a backlog. It backs up like a traffic jam. Okay, so that means you can only go around all at the same speed, which means that the current for this one is going to be the same as the current for this one. It's going to be the same as the current for that one. So in series, current stays the same. All the way around the circuit. That's the first thing. Second thing. What about the energy? Okay, so if we look at this again, and now we want to have a look at what's happening to my energy. So I've got my 3 cells again, and I've got my 2 resistors, and I want to look at my energy in my series circuit. And we did this one when we looked at potential difference. If this is 6 volts, then I know that these 2, they have to split that energy evenly. So I know that this one is going to be 3 volts, and I know this one's going to be 3 volts. And I know that the difference in energy that an electron has here compared to an electron here is going to be going from 6 volts here to 0 volts here, so I know that's going to be 6 volts. So in a series circuit, the current stays the same, but the potential difference is spread out across the components. Okay. And the last thing, so far we've done current and voltage and what to do about adding up the cells. The last thing that we have to add up is if that one was a 100 ohm resistor and that one was a 100 ohm resistor, then the total resistance in a series circuit, you just do R1 add R2 equals R total. So our R1 was 100, our R2 was 100, so that means that R total equals 200 and the units for resistance is ohms. So all you do is add them together. And remember, the split is based on how hard it was to get across. So let's say, for example, that this one wasn't a 100 ohm resistor, let's say that one was a 200 ohm resistor. Now it is twice as hard as this one, so the energy would be twice as much to get across this one as it would be to get across this one, which means it would be 4 volts here and 2 volts there, because it would be twice as big as this one.